Welcome back. We are moving to Investigation 3, and this section is about something called an inverse variation. And basically what inverse means is that as one of the values goes up, the other value goes down. So as x goes up, y goes down. The opposite thing is happening. So we're going to read this little story about this small town, and they're offering free lots of land, and it has to be a 21,800 square foot. We could convert feet to inches, but what you would need to do is 21,800, and then there are 12 inches in a foot, but this is two-dimensional. So the number that we're multiplying is 3,139,200. So the two numbers need to multiply to give you that number. So if you have a length of 1 inch, your width would have to be 3,139,200. If your length is 2 inches, you would have to do the whole 3 million divided by the 2, and you would get 15,69,600. So 1,569,600. If you divide by 3, you would get 1,046,400. If you divide by 4, you would get 784,800. If you divide by 5, you would get 627,840. If you divide by 6, 523,200. If you divide by 7, you get a decimal. $448,457. And if you divide by 8, so again, all of these, you're just taking 3,139,200 and the length times the width, so this is the x and the y, would have to equal 3,139,200. So if you want to solve for y, you would divide by x. So 3 million divided by 8 is 392,400 inches. Okay, so that's some large data. So now we're going to plot the data. Okay, so we have 3 million is as high as you go. So you're probably going to want to count by 1, 2, 3, 4, 5, 6, 7, 8. Probably by 100,000. Probably by, because you want to get to 3 million, not 1 million. So probably 500,000. Yeah, let's go with that. So 500,000 inches. So this would be a million. Skip 1, you have 2 million. Skip 1, you have 3 million. And then the x value can just go by ones. And then the title's already given. So in order to plot this, 0 was 3,100 something or other. Let's see, 2 was 1,500,000. 3 was just a tiny bit above a million. 4 was 784. 5 was 600 and something. 6 was 523. 7 is 300 something. 8 is also 300 and 7 is 400 and something, and 8 is 300 and something. Okay, so the middle digits, would those work? Could you have like a side length of 1.2? Yes. So we're going to connect this inverse graph, and it looks like that. So as x increases, y decreases, and it decreases, if you look at the graph, the very first chunk, this is the steepest part. Then it's getting flatter and flatter and flatter and flatter and flatter until there's not much change at all. So as x increases, y decreases less and less. And that's how we know it's an inverse. Is it linear? No, because x times y gives you the 3,139,200. And if it was linear, you would have something in y equals mx plus b. And that is not the case. So if you had an area of 24, which is a much nicer number, you would have length times width is 24. That's x times y gives you 24. So you think of all the numbers that multiply to give you 24. And to get that, you would just do 24 divided by each number. So like 1 would give you, first of all, 0 you cannot plug in. 0 would give error. And I think that I actually graphed this incorrectly. It just came to me. Yeah, this is 1. 1 should be right here. That should never cross the axis. Holy cow. Aren't you glad I figured this out? Hopefully you were confused. Okay, so 1 is a little over 3, whatever. So this swipes up, and it never touches this x-axis because the 0 is error. You cannot divide by 0. In fact, this is called something special. It's called an asymptote. We will do more with that momentarily. Okay, so back to this. So 1 would give 24 because 24 divided by 1 is 24. 2 would give 12. I did 24 divided by 2 to get that. 3 would give 8. I did 24 divided by 3. 4 would give 6. 24 divided by 4. 5 is a decimal, so we'll just skip it. All right. Now it says if you have an area of 32. So x times y would give you 32. So you would have 32 divided by the number to get your answer. So again, 0 is an error. 1 would give 32 because 1 times 32 is 32. 2 would give 16. 2 times 16 is 32. 3 is a decimal. 4 would give 8. 4 times 8 is 32. 5 is a decimal. 6 is a decimal. 7 is a decimal. 8 would give 4. You don't necessarily have to put the decimals in. They're going to show up in your graph. So we're not going any higher than 32. So when you go down here, oh, it's a big table graph. Length, width, and we'll just title this area of 32. So we're going to count by ones. We sort of ended at 8. It would end at 32 because 32 would give you 1. Maybe count by 5s here. And then plot your points. Remember, 0 is an error. 1 is 32. 2 is 16. 3 was some decimal. 4 was 6. 4 was not 6. That's 24. 4 is a decimal. 4 is 8. 5 is a decimal. It's 6 point something, so you can approximate it. 8 gives 3. 4. Wow. 8 times 4 is 32. 8 gives 4. Okay, again, you can connect this. And that's an inverse. How are these equations similar? They are all y equals some number divided by x. How are they different? The constant number is different. And then how are the graphs similar? Well, all of them look like this. And they don't touch either axis. These are those little asymptote things. How are they different? The bigger the number, the steeper that they start. Whereas smaller numbers are flatter. So you might have something more like this. That might be a smaller number. They're all going to sort of converge to 0. Oh, that's the end. Okay, so that is 3-1. I kind of made some mistakes in there. Sorry. I'm so glad that you are so flexible and calm and relaxed during this. So I'm hoping that this makes sense. Remember those asymptotes. Remember the inverse doesn't touch. I'll give you one more little word, and that word is hyperbola. Whenever you have y equals something divided by x, this signals that you're going to have a hyperbola. And if you have a table and you're wondering if it's going to be this, I'll give you a table actually. How's that? So this is your table. 1 gives 50. 2 gives 25, 3 gives 16 2/3, 4 gives 12.5, 12 and a half, 5 gives 10, 6 gives 8 1/3, that's enough. So when you have your table, the first thing you want to do is say, is this linear? And the answer is definitely no, because it's a difference of like 1 2/3, a difference of 2 1/2, a difference of 4 point something. So it is not constant. And it's not even in a pattern. So the next thing you do is you multiply. 1 times 50 is 50. 2 times 25 is 50. 3 times 16 2/3 is 50. Isn't this fascinating? 4 times 12 1/2, that is 50. 5 times 10 is 50. And 6 times 8 1/3 is 50. So the way that you write the equation for this is that x times y is 50. And then you can solve for y by dividing by x. And that is a hyperbola. That's going to give you the curve like this. And that is what this lesson is all about. So hopefully you are one with it. Have a beautiful night.